Kia ora koutou katoa, it's Mrs. Goodson here, and this video is about properties of ionic compounds. It's part B, just to make the videos a little bit shorter, and the first video looked at conductivity of ionic solids, why they have really high melting and boiling points, and also why they're brittle. This video is going to look at why ionic compounds dissolve. Now, some ionic compounds dissolve really easily, like table salt, sodium chloride, and others like calcium carbonate are only sparingly soluble. But we're going to look at the properties of why the bonding and structure of ionic compounds allow them to dissolve. So first of all, thinking about what is in a solution. A solution has two parts. It's got a solute, that's a thing that's being dissolved, the solid that's being dissolved, and the solvent is the thing that's dissolving it. And now we're usually thinking about water being the solvent because water is such a good solvent. It's really important in nature. So when an ionic compound dissolves, the ions get pulled apart. Okay, they get pulled apart. The bonds get broken and they diffuse. That means they separate in the solution. And the solvent particles, and in this case, it's the water particles. So that's the water molecules. And in this picture, these are the little water molecules here. Water molecules. 1 oxygen, 2 hydrogens. They end up surrounding the ions, okay? So the ions get separated. So we've got positive ions, in this case, the sodium ions and the chloride ions, and they get surrounded by water molecules, which there's a lot more water molecules in that solution. And so the solid, this part is the solid, is going to get pulled apart. So this is another video to watch about what happens when stuff dissolves, and it compares molecular substances like sugar with ionic substances like salt. So we said how the water molecules have to surround the ions. And so there has to be some bonding between the ion and the molecules of water. And that's what holds the solution together. Now, water is polar. Now, we're going to get into that a lot more in future videos. But polar just means that one end is slightly positive and one end is slightly negative. So the end that's slightly negative is going to be attracted to the positive ions, and the end that is slightly negative is going to be attracted to the positive, and the end that's slightly positive is going to be attracted to the ions that are negative, because opposites attract when we're talking about charges. So because water is polar and it has this special property that one end of the molecule is slightly positive and the other end of the molecule is slightly negative, it's going to be attracted to the ions, and so that's going to pull apart the lattice. Okay, so here it is in words. Now here's another good picture which shows these little symbols here means slightly. Okay, so this is a water molecule with the oxygen. The oxygen end is the one that's slightly negative, and the positive end is the hydrogens. And so in this case, it's attracted to the negative chloride ion, and so the positive, it lines up so that the positive end of the water molecules surrounds the chloride ion, whereas if it's the sodium ion, which is positive, then it's going to be attracted to the slightly negative end, or partially negative end of the water molecule. So water is polar, so it enables water to dissolve many ionically bonded structures. Salt is made from positive sodium ions and negative chloride ions, as we've said before. So water can dissolve salt because the positive parts of the water molecules attract the negative chloride ions, and the negative part of the water molecules attract the positive sodium ions. The amount of substance that can dissolve in a liquid at a particular temperature is called the solubility. And as I said, some ionic compounds are a lot more soluble than others. The substance being dissolved is called the solute, and the substance doing the dissolving is called the solvent. And there's just another video to reinforce what we've been talking about if you would like to watch that one. So in an exam question, you might be asked to justify why a particular ionic compound is soluble, in this case, potassium chloride. So if the first part is you just state the bonding and structure. It's an ionic substance, it's got positive ions and negative ions held together with strong electrostatic forces in a 3D lattice. So that just gives you a tick. We've stated that we know about ionic compounds, the bonding and the structure. So then you have to relate to the question. So soluble means why does it dissolve in water? The ionic lattice is going to break up. And the reason is that water molecules are polar. The positive hydrogen ends of the water molecules are attracted to the negative ions, the chloride ions in the lattice, and the negative oxygen ends of the water molecules are attracted to the positive ions. Now, and the attraction of the polar water molecules for the ions is sufficient to overcome the attractive forces between the sodium and the chloride ions, allowing them to be removed from the lattice. Hence, so that's all because. So you need to, or so therefore, these are the kind of words you need to use to justify, to give the reasons. The sodium chloride solid dissolves, forming separate sodium and chloride ions in an aqueous solution. That just means in a water solution. So there's another video that you can watch just about the which sums up all the properties of ionic compounds that we've talked about. So in this video, part 5b, we have explained why ionic substances are soluble in polar substances such as water.